staining of typical nucleus edge. Now, what are those two reasons are there? One is known as euchromatin and one is known as heterochromatin. So, come on that. Euchromatin and one is two reason is that one is heterochromatin. One is euchromatin and one is heterochromatin. Now, what are these? So, euchromatin means loosely packed. They are having euchromatin. This is loosely packed chromatin fibers. So, it is loosely packed. Heterochromatin, this is densely packed. Okay, this is having what? Densely packed chromatin. Here what happens? If staining are coming, so it is lightly stained chromatin. Lightly stained chromatin are found in euchromatin. It is darkly stained. This is darkly stained chromatin are found in heterochromatin, and this euchromatin is useful in transcription. So what we can say, it is transcriptionally active. Okay, this is very important. Which one is transcriptionally active? So that is euchromatin, and heterochromatin is transcriptionally inactive. Transcriptionally inactive chromatin. So these two reasons are found. Okay. Now, what happened? This packaging of histone, okay, or what we can say, this packaging of DNA helix, or what we can say, this packaging of chromatin at higher levels require further set of protein because complexity increases. So further set of what needed? Proteins needed, and that collectively known as NHC proteins. What I told? I told that packaging of chromatin at higher level. Okay. Packaging of chromatin at higher level needs more non-histone basic proteins. Now they need what? Non-histone basic proteins known as NHC. So they are knowing as what? NHC. That is full form non-histone chromosomal proteins. Non-histone chromosomal proteins. Okay, this NHC full form is non-histone chromosomal proteins. Where it is needed? When higher level packaging of chromatin needs. In that case, non-histone protein is being needed. Okay, now if we are seeing the importance, one or two points we have to see. What we have told, that H1 is not a part of histone octamer. So note, it is having note. H1 protein is not a part of histone octamer. Very important that H1 protein is not a part of histone octamer. What it is doing? it only plugging, only what it is doing, attaching. So it only plugging, that sealing the incoming and outgoing DNA. So what I told, it plugs the sealing of incoming and outgoing DNA, and that's why, since it is only plugging, and that's why H1 protein is not the part of histone octamer. If mathematically I want to show that one nucleosome is what, so one nucleosome is equal to what we can say, histone octamer, histone octamer plus 1 is to 3 by 4, okay, turn of DNA, turn DNA. So this is completely known as one nucleosome. This you have to remember. Okay, so one nucleosome is histone octamer plus 1 is to 3 by 4 turn DNA. Okay, now one question is there. Question is what? Enumerate the number of beaded structure. Question is there. Enumerate the number of beaded structure. Now we know beaded structure means what they are telling, nucleosome. Okay, so present in, so what we have to know, it is what, nucleosome, present in nucleus. Okay, they are telling present in nucleus of diploid eukaryotic cell, presents in nucleus of diploid, this you have to remember, diploid eukaryotic cell, okay, diploid eukaryotic cell which possess, which possess, now they are giving what the amount quantity is there, 2.4 into 10 to the power 6 base pair, 6 base pair. Okay, now option is there, 12 into 10 to the power 3 nucleosome. Okay, second, 12 into 10 to the power 6 nucleosome. Third, 4 into 10 to the power 3 nucleosome, 4 into 10 to the power 3 nucleosome, and D option is there, none of these. Now, how we will solve this? They are asking what? Nucleosome, and we know that one nucleosome has how many base pair? 200 base pair. So, one nucleosome has 200 base pair. So, how we will count that one? Here given what? 2.4 into 10 to the power 6, and by we have to divide it with 200. So if we are dividing to 200, so it will come what? This is 200, so it will come 2. So 12 is there. Okay, so 2 4 by this will come here 1, so it will come 2000 or into 10 to the power 6. So what we can write? 24 by 2 into 10 to the power 6, and this is 3 into 10 to the minus 3. This we can write. So it will come 12 into 10 to the 6 minus 3, so 10 to the power 3. This is the number of nucleosomes. So what will the answer? 12 into 10 to the power 3. Okay, that is the number of nucleosomes. Understood this one? So this is the important topic that many questions while this giving lecture I have seen. Okay, next we will see further topic. Okay, thank you. Replication is there, transcription, translation we will see in the next lecture.